Hi. Welcome everyone to the July 7th SIG Apps meeting. I'm your host today, Janet. And today we have one announcement. The 134 code freeze is coming and SIG Apps is calling for exceptions if you want to add some exceptions for enhancements. Then we have two topics for discussion today. The first one is about relaxing the immutability of plot templates in jobs. We have someone.
Yeah, sorry, I forgot that. That was for me. I'll add myself to that. I'll do that after. So I kind of started this discussion thinking about the next steps for in-place pod vertical scaling, and I had a kind of a client meeting with someone where they had a use case where they want to use some kind of external service that will rebalance workloads. So, like maybe somebody specifies let's say, for example, they request 4 GPUs, but then they really only need 2. The idea was that a job should start in suspended, and someone should be able to patch the resources to lower the resource requirements. And I'm kind of been thinking that, this is another use case is obviously with in-place pod vertical scaling, like people would want to resize the pods as they're running. I brought this to Signode, and I think for in the case of a job being suspended and pods are not running, that's not really in-place pod vertical scaling's problem, and it's more of like a workload API kind of perspective. So I kind of uh, am thinking that I had this laid out as kind of some options, but I was thinking going forward, I'd like to kind of tackle a case when jobs are suspended. We hopefully can be able to change container requests and limits. And in the agenda, I've kind of drafted a proof of concept, and I wrote a KEP for it. And I was curious on whether or not we can consider it for 1.35 and whether or not there's any issues about allowing people to change the resources once in this case jobs are suspended.
So I think one of the concern is about complicating the controller logic. So I want to understand uh, the reason of making this change. Is vertical pod autoscaler not enough for such a use case? Because
Well,
vertical VPA can directly touch the pod without interfering with the pod template.
yeah, I mean, that can be in the case of running, I believe, or but if we want like an audit on the workload, I think having the workload API kind of have a reflection of the change is also, I think it would be nice from to be able to kind of see, like, someone patches a workload, they actually request less, they could actually see like what they have requested. And having like something like queue will actually, like, the requests there would say like, oh, I actually want, I went from 4 GPUs to 2, and then the queue request is actually requesting 2. If we go with pod vertical scaling, then, well, for one, there's not yet support for that for something like queue, where you are changing a workload as it's running. That's past the emission stage for queue. So it gets a little bit trickier there. So part of the reason why I wanted to do the suspend is to kind of allow someone to use like changing the request before a workload is actually scheduled, and then have it go through queue for admission, and then have it run like with the actual requests and limits. And that's one
So,
reason why I
so another alternative um, is to kill the job itself and recreate a job with a different resource request and limit, it will
Yeah,
be somewhat similar to suspending it and then changing the request and limit.
yeah, I guess that is fair. But that wouldn't really that kind of from like if an end user like submitted a workload and then a separate controller killed it and then it gets recreated, how does I guess it gets a little harder to discover that new workload that was created, right? If it gets deleted and then recreated like from an external controller, it makes it harder to track that job.
So you are
And I
thinking about an external controller instead of the user who is doing the suspending and changing the
yeah, like
resource
I mean,
request limit.
yeah, the example that someone brought to me was an idea of having like somebody requests a job and then it's, let's say the model can actually fit on 2 GPUs instead of 4. You can lower the user's request of the workload so that it's actually more optimally more using its resources, and then that request goes through as normal and they're able to kind of track that job. And then that was kind of the main use case that I was seeing there, and that's why that's why I was kind of going through thinking about like with suspended. We have an example where suspended was like when jobs were suspended, we did allow for you to change scheduling uh, heuristics like node selectors and other stuff as part, and it was kept from maybe a few years back. And so a lot of the change, to answer your question about controller logic, it's actually primarily contained in the update logic from just doing updates of jobs. Like there's nothing changing in the controller here because it's all part of controlled by an update, at least for the first idea I had. Uh, Ela, sorry, even patient. Would you like to go next?
Now we have a hand.
Yes, my question was pretty much similar in line what you just follow up with the job recreation. Essentially, if you today in Kubernetes, when you suspend job, you kill all the running pods, right? So it goes into basically the state where it exists, but it doesn't really run anything. So what the goal is for you is just be able to modify those jobs. And then when you unsuspend them, then pods will take effect with new requirements. Your controller, external controller, just to understand better the case, it manages the state of existing job. So it looks on the job and looks on the resources available and alters the job resource requirements. It does not necessarily manages the life cycle of a job of creation and deletion. Where you considered the option, maybe I'm repeating the question that Janet just talked about, just considering the question that your controller will actually, instead of editing the job, will be able to recreate the job.
I mean, that could be an option. Like, I mean, yeah, there's always an option there. I partly am thinking like, if we go that route, though, if we tackle like in-pod vertical scaling, like we cannot really like deleting a job and recreating it goes against the whole point of that feature, right?
Oh,
So
yeah, I
like,
totally understand. So with the pod scaling, we kind of launch into different domain of running pods, adjusting resources. So it's related, but it's slightly different problem, or maybe a little bit more complicated problem. But yeah, okay.
and I was not the author of the external controller, but it was just a use case that someone kind of brought up, and I was just thinking also with in place pod vertical scaling, I was thinking about like we have a couple different use cases where people may want to like whether or not we want to go through the workload. Like, I mean, there is always an option where like you create a job, it creates those pods, and then you can always resize them using in-place pod vertical scaling at the pod level, and you don't have to go through the workload at all. I think that gets really hard on queue, I think, because like if you're changing the pods, that completely changes at the workload level what you were requesting. So I was thinking it would be nice to kind of have this information from the workload down so the workload could react better to like an in-place resize of the underlying pods versus like someone having to manually go through every single pod and kind of not manually, but they would have to go through all the pods to change that. And then I don't know if the job controller like would react to that correctly or not. Like that's kind of where I was thinking of like more audibility of this feature and thinking like if I change the request, at least I can look at the actual job request and see it was modified versus somebody doing it on the pod level. But yeah, I guess is it considered not like is it rather like the approach for this would just be to delete and recreate and we don't want to add this feature?
It's more about understanding the why behind the change before saying yes.
Okay. I did write a cap. I mean, I talked more about it there, but not much more details than probably what I mentioned here. But yeah, partly the idea was rebalancing requests and setting them different values. But I can see why at the end of the day, I mean, you could always recreate them separately. So
Maybe a
I'm
little bit
also,
of color to that. I'm sorry, John, go ahead.
oh, I'm also thinking about a potential race case that you change you change suspend to true and you change the resource request and limit at the same time, and then quickly you change the suspend back to false. With the job controllers, he's didn't see the change of suspend and then tries to adjust the resource request and limit when the job is still running.
yeah, I'd have to test that. Yeah, I don't know. I mean, I know that like we already have an example with changing the scheduling requirements. So I know when you suspend or unsuspend, it does start terminating those jobs, and then it would trigger a new rescheduling loop. So then they would be probably scheduled with the new requests.
Yeah, unless there is a race condition in the job control itself, I would say that it's pretty safe to assume that suspend will terminate all the pods and make sure new created with new spec. I wanted to add a little bit more in terms of specifically queue use case. When a queue processes the job, essentially it provides the curated experience for users. Users create the job, but queue then kind of takes over and does this additional controlling of this job object. So it's not straightforward use case, but that's the case where you have an external controller that can suspend and unsuspend job. What I guess the ask is here is in addition to suspend and unsuspend, it may use additional heuristics to adjust the requests. So my concern would be maybe is that I think it's fine in general, but maybe considering the use cases where jobs being created by some sort of automation or CI/CD pipelines, and where now you create disconnect where one system tries to assert the spec to certain resource requests, while another controller will try to now update that spec to something else, and maybe have this feedback loop where two controllers trying to update the job spec.
Yeah, this is kind of a major race right now. Like if you're using suspend, I like to think Q kind of effectively calls dibs on it and it will use it no matter what. And if you like I've seen some use cases on JobSet and others where people are externally using the suspend for the behavior, but then if they use it with Q will unsuspend as long as there's capacity. So it's kind of like Q has effectively called dibs on that field. And I mean, there are workarounds, like some examples I've seen people say is you can always, for Q, you could set it to a non-existent like local queue and have it kind of start suspended so that queue will never resume, and then you can kind of patch it, like do what you want with that workload and then change the local queue and that can reschedule. There's been another KEP that was, or an issue that was proposed around this concept of a readiness gates for jobs where you would add like effectively you would add scheduling gates but at the job level to kind of replaced a lot of the idea of suspend, but I don't know if I haven't seen as much use cases that really dictate like why we should go about that yet, because it does mean we have to kind of deprecate the suspend field in place of a readiness gate, which seems to be more invasive. And I don't know if I've seen no one's really picked it up yet to kind of lead that effort. But yeah, and part of the reason why I'm also coming here is job is a critical component for JobSet, and we kind of run into this problem where, like, for JobSet, if I create a JobSet in a suspended state, unfortunately, I created the jobs in a suspended state, and then now what that means is I can't actually change anything. I can't change any of these resources. I can always create them, and I was thinking that there might be, use cases for that's why I was just thinking it would make sense to me why, like, suspended a job, you can change things, and then that also in turn plays at like a job set level. You can change the jobs before they fully get scheduled. And then I know for Kubeflow is also has a dependency on job set, and they might have cases where they want to change these resource requests at the workload level. But anyway, I believe I will maybe try to think more about some other use cases. I know the other area that I think I need to also look more into, and I don't know if this is really in SIG Apps scope, but added a comment on the issue. I'll share my screen. About for DRA, I was thinking a little bit more about this. I'm sorry, I can't share. Can I get Hostak or quick
Yeah,
access
I
just to
just
share?
gave you access.
Okay, thank you. So basically, I mean, with the KEP, I kind of go through this example for device plugins and classical resources. So, CPU and memory, you can patch the job when it's suspended, and it will change the resources fine. This gets a lot harder with DRA because obviously in a job in a pod template, you have requests, resources, and limits. You can change those. It isn't as clear to me on DRA how we would approach this because I was playing around with this over the weekend, and we effectively DRA has a concept of a resource claim, and then a pod spec references that claim. Resource claims are immutable once they're created, and you can never change them. And then in the pod template level, we also don't allow people to change the claim for a pod template. So there's a couple options there. I was thinking about taking this to device management to kind of think about like what are some options there, because I don't know if, like, as we're thinking about mutability, especially for resources, I don't know if we should target just like device plugins and classical resources and leave DRA with not having a path forward. So I was thinking I was going to take that to device management this week to kind of discuss. Because yeah, in this case, like for DRA, obviously someone basically they can create a new resource claim, and then if we relax the immutability, they could always change the claim on the pod spec to point to a new claim. And that's at least to me a little better because they can at least it shows the change of the workload. And then the other option, which is they could someone could actually patch the resource claim template, and then workloads. Like if we relax that without the workload level, then a workload could get the new changes. I don't know if that's really the best approach, but maybe I'll have to take this to, I think, device management and kind of discuss a little bit more about like if we do relax the immutability for this, like what is the like what's the path forward from at a workload level. So anyway, I'll think more a little bit on some use cases and kind of see. I have the PR available for people to view, and I did draft a KEP on it. And so we can, obviously we're in 1.34 cycle, so I don't expect too much people to review it right now, but I have those in the links if people want to take a look. And that's kind of all I have. Any questions before next time?
No. So I'm going to take a look at the CAP in more detail, and I'll also ask the other SIG Apps leads to take a look.
Thank you.
Let me share. The next topic is about the deferred resource quota enhancement.
Yes, that's by me. I'm Ilya. And this is actually a pretty good segue from the previous Kevin's presentation, a related topic to, I guess, dynamically changing requirements. But in this case, I'm looking from a different angle. And I think Kevin mentioned something in terms of pod scheduling gates as an alternative to a job suspend. Just kind of brief overview. And I don't know if I can share, I guess maybe pull up some web page.
Yeah.
Let me see.
Gave you access. You should be able to share.
So if I cannot, let's see, maybe it takes time. Okay, here, now I can see. Share. Let me know if you can see my screen. That should be like web page.
It works.
Excellent. Okay, so in Kubernetes, we introduced construct of scheduling readiness gates where pods allowed to be created, yet they're not eligible for scheduling. So in pod spec, there's a scheduling gate slice of strings where you can specify that one or more scheduling gates entries. Effect of that is that scheduler will ignore this pod for scheduling. So as long as there is a scheduling gates present, it will not schedule pod. Until scheduling gates list become empty, then we can schedule pods. Scheduling gates is mutable field, so whoever create pod with scheduling gates can also, given right RBAC, reset the gates, so remove the gates. It's maybe kind of akin to finalizers in reverse, where you have finalize, you can delete pod, or it will not be garbage collected, and then it will be garbage collected. So, and it's actually very powerful feature, enables a lot of interesting orchestrations at the pod level, where you can create the pods and wait until certain conditions are met in terms of resources, for example, and then ungate the pod, allow them to proceed through scheduling pipeline, and then go and run. What it creates a little bit interesting use case, however, when we start dealing with resource quota. The scheduled gated pods are counted towards resource quota. So while it is possible to create any number of scheduled gated pods, you will still be subject to quota enforcement. And it is possible to kind of paint yourself in the corner where you create too many scheduled gated pods that you exhaust the quota. And then the pods which need to run to, let's say, reset those scheduling gates won't be able to run because there's no quota in the namespace. The resource quota enforcement happens at the admission time. So when you create the pod, and the resource quota controller will check, do you have enough quota in your namespace? And if not, it will reject pod creation. So what I want to, with this kind of conversation, or begin the conversation, if there is an interest or if there is a kind of desire to revisit the combination of this resource quota enforcement and calculation and schedule gated pods in terms of that it will be nice to enable feature where we can defer resource quota validation. For example, if we have a pods which schedule gated, we can still count them towards some count quotas, let's say how many count pods being enforced in the namespace, yet we don't count them towards the actual resources utilization. So other pods can continue run, be scheduled and run and go out of scope while the conditions are met. And then we enforce quota, like for CPU and memory, on the schedule gate removal. And I have a quick POC. If there's an interest, I can quickly show you the kind of in action, how it may look like. Let me just switch sharing to another terminal. Let me know if you can see my screen again. This time it should be a terminal screen.
Yeah, we can see
Right.
it.
So this is just a basic Kubernetes client cluster, and just to show the construct of how the schedule gating works today. So, oops. Is it okay? Unfortunately, it blocks my view of the pencil. Oh, here we go. Maybe it's better. I'm missing this up. I'm sorry. Okay. So what I will do in CTL apply this pod. So this is a regular pod with requesting one CPU. I have a namespace which allows me hard quota of 2 CPUs. 20 pods and memory is kind of consequential right now, but mostly focus on CPU. So when I create this pod, you notice that the CPU being adjusted, used 1, now remaining 1 CPU, and everything else accordingly. So if I create the schedule gated pod, for example, if you have a schedule gated pod, if I create it similar way, you will notice that pod is in pending state because it's schedule gated, nothing is running. However, the CPU and memory and all resources being adjusted accordingly. So now if I would like to, let's say, create another pod, let's say a normal pod, what I will see is I'll get this message. This is the resource quota enforcement and admission time. The admission failed. So, and that's the current Kubernetes behavior. So now I switch to another cluster where I have a hashed version of resource quota controller and scheduler. And we're going to go through the same example again. So if I create this pod, same thing happened. However, now if I create the schedule gated pod, oops, it's always okay. I have a create pod. So, but in difference here is notice that the CPU is not being adjusted. So now resource quota ignores this pod, saying, "Hey, I understand. I'm still going to count as a pod because it's created here and it's in pending state." Now, if I if I watch this status, so it's kind of blocked by scheduling gating, but it's not counted. So now, if I would like to create another pod, say normal pod here, I can create that pod and it will be consumed quota. So now in this scenario, I'm slightly over-provisioned, if in a strict sense, where I'm having another pod sitting here pending, but now that pod is not blocking the quota. So anything else which fits within the quota can run. What makes more interesting use case now, what happens if I remove the schedule gate? And we're just going to comment this out. That's the effect of removing scheduling gate by controller or user. The status of a pod rapidly changes to now the scheduler start invoking processing on this pod. And it says, hey, I cannot schedule this pod because you don't have enough quota. So it's in scheduling loop. It's being processed by scheduler, but pod is being now pending still. And what happens now if I, let's say, oops, if I delete one of the running pods, say normal 2. Right, so of course I have this in block. So now you see the schedule gate pod automatically resumed and status being updated accordingly. So this is just the quick POC of how it could potentially look like if we implemented deferred quota enforcement. Why is it important and where it kind of come into place? Anywhere where we use pod scheduling readiness gates, this can be very helpful to orchestrate more complex solutions where you have one pods as dependency requirements for another pod. Essentially, they will not be deadlocked in this case. One good example comes in mind, and I think today's meeting is going to be heavily queue influenced. It's queue as well. Queue is using pod scheduling gates to prevent pods from running, specifically when they use pod integrations. But also, as just Kevin mentioned earlier, there is conversation of potentially considering scheduling gates for other use cases. So where I'm going with this, I would like to start this conversation and see if there is an interest or if there's any feedback or maybe obvious blockers and non-starters saying, hey, we should not do that, and potentially propose a cap to augmented functionality for both resource quota controller and scheduler. In other words, so that we can support the use case.
I think this proposal makes sense. I want to understand why it isn't implemented that way initially. Was it discussed before, or it's not thought about it?
Yeah, that's a very good question. I reached out to, I'm still waiting for comment from the implementer and proposal of the person who proposed the schedule readiness gates. But from what I understand from early exploratory conversation, it looks like maybe it was an omission when we introduced the pod scheduling readiness gates functionality that there was no close coordination. With all fairness, there is similar behavior can be exhibited today without pod scheduling gates. For example, consider the use case where we can create pods which cannot run. For example, we have entire cluster with the tainted nodes, non-schedulable. So you still will be able to create the pods which will be counted towards your quota, but they will not be able to run. So it's maybe similar use case in a sense. I think scheduling gates, it's a little bit different because when tainted nodes, it's more extreme use case of degradation in performance, or cluster goes in bad state with all my nodes in non-schedulable. With schedule gate, its main feature, we actually want to pod not to run, not to schedule until certain conditions are met. However, those conditions can be impacted by the fact that now there's no capacity in the namespace to run. And I think that's what we're trying to investigate in this example and maybe propose as a cap.
Yeah, sounds good. I think I'm supportive of this proposal.
Excellent. So what I will do in next step, and hopefully for the next meeting, I will draft the cap and maybe even do the POC. So this way, next time we can maybe review something in more concrete details versus me waving my hands here and just doing quick demo.
Does anyone have any questions about this proposal or feedback?
I guess I was kind of curious from, I've always been wondering, like, for queue and resource quotas, do you see a lot of use case for having both? or because like Q is kind of a way more advanced resource quota controller?
I do think one use case I see immediately is the migration path. So we're going to have customers or users of Kubernetes who currently leverage in resource quota. And if they want to adopt the queue, they will be faced with the dilemma. Do I abandon my resource quota in favor of queue, or do I maintain queue exclusively? There are some interesting observations about queue quota management. It is more advanced in terms of borrowing and all this other without going into details. However, queue does not necessarily blocks things on admission how resource quota does. And it slightly creates nuanced computation of the quota, what considered to be countable, whether workload is admitted, what is not admitted, and so forth. So I don't know, to answer this question, I don't know if the users would like to use both. I can see it both ways, where they can use one or another or combination of both. With that said, I think the pod scheduling readiness gates and resource quota problem, as framed in here, exist even outside of realm of queue. Basically, anyone who uses the pod scheduling gates will at some point face this problem and say, hey, I create a bunch of pods, they're not ready to schedule yet, now I depleted my quota.
Yeah, and I think that makes sense. I mean, I can fully see why this should be added as a KEP. I think that it's definitely, I think it makes sense because the scheduling gate is not scheduled, so it shouldn't be using those resources and from a quota standpoint.
Yeah, and I think what Janet has mentioned that I think what initial thought I'm guessing here now is that was what we counted used as a potential to be used. In other words, that pod has a potential to run. Whether it can run right now or not, it doesn't matter. The fact is that it has potential to run. We're going to count towards the quota. And that's something maybe we can change. Or introduce more nuance to it.
I am curious on is SIG Apps the owner of resource quota?
So I asked this question in the SIG scheduling, and I've been told like you should bring this up in SIG Apps. So that's why I'm here.
I mean, I wasn't, I haven't really looked to see, so I was kind of curious.
No,
Yeah,
SIG Apps is not the owner, but I think it's related to workloads. That's why it's brought up
Okay.
here.
Yeah, I'll be bringing this up also in the SIG scheduling as well, just to complete the loop.
Yeah, and I don't think either way. Yeah, I don't think it really matters. I have a feeling this is in the gray area. I looked at the owner while you're on the call, and it doesn't look like the owners of the resource quota have changed very much since it was first created. So,
Cool.
But it's cool.
Right. Does anyone have anything they want to bring up or talk about? Right. I think we can end the meeting. Thanks everyone for joining us
Thank you,
here.
Toby. Mhm.